Yes, sir. Recording has started.
Okay. So today we will learn about the analysis of variance with repeated measure. Earlier we have understood analysis of variance without repeated measure, but today we will learn analysis of variance with repeated measure. So what is the difference between the two? In case of the repeated measure, we have the data from the same person for different periods. Okay, usually it is used for psychological test construction and for assessing the effect of some medicine on disease control. And this test is very, very useful, specifically who are doing research in experimental method. So just like the ANOVA without repeated measure, ANOVA with repeated measure also assumes the normality. Therefore, initially you have to check your data whether the data follows the normality or not. And in case of the ANOVA without repeated measure, you have variables with two levels, and your dependent variable will be the metric. Like that, in case of the ANOVA with repeated measure, your dependent variable will be the metric data. But keep in mind that this metric data is the periodical data. That means when you have administered the intervention, at that time you collected the data. During the mid period, you collected the data. And after the intervention, again you collected the data. It may be pre-intervention, mid-intervention, and post-intervention. Or it will be between periods for your experiment, For example, I collected data from the 11 Antarctica expeditioners over 12 months. And I want to examine, that is, whether the state anxiety level is changing across the months or not. Now, in this condition, you have to follow this format in SPSS. Now I am sharing the screen. Please follow it. I think this is visible to all of you.
Yes, sir.
So here you can find out this is the variable view. I want to show you the variable. So this is the variable view. Your first will be the group that will be the string data. Next one, day 1, day 2, and day 3. They are the numeric data. And all the data will be the nominal. Okay. Now I am going to the data view. So here you can find out the control group and the treatment groups are there. And day 1, day 2, day 3. So data were collected from the same individual. Here control means same individual in the control group. This is also the same individual. Okay. Now you have to click the analyze. After that, general linear model. General linear model, in case of the ANOVA, without repeated measure, you have used univariate. But here you have to click the repeated measures. And here you can find out the 3 levels are there. 3 periods are there. Okay. So they are the 3 levels. So instead of the factor, you can write down time. After that, 3. And this is the cholesterol data. So this measure name is cholesterol. This is clear. For example, here you can write down factor. In this factor, here you can write down time. Okay. And here you will write down 3 because you have the 3 periods. Then you have to click the add. Like that, you have to write down what is your measure. Here the measure is cholesterol level. So cholesterol level change or not, that is your target for assessment. After that, you have to click the define. Okay. So when you click the define, when you click the define, it goes to this, show this group. First one is the group. That will be the between subject factors. And within subjects variables are your day 1, day 2, day 3. Okay. So for example, I am showing you. So this is the day 1. It will go to the first place. Day 2, it can go to the second place. And day 3, it will go to the next place. Okay. And if you want to change the order, you can change the order also. If you want to change, you can order. But I am not interested to change the order. Now this is the group. Group is the between subject factors. After that, you will click the model. You have checked this is the full factorial model. Next is continue. Next you click the plot. So it is written group. Group as the separate line and time is horizontal axis. Then you click the add. So if you click add, then you will get the time and group interaction. And the chart type will be the line chart. Next, you have to click the continue. Then OK. So now you have noted this is the output. I am sharing the output. So here again you can find out it varies over the time. Okay, this Will's lambda is 0.07 and it is highly significant, 0.001. That means over the periods, the cholesterol level changes. But in case of the interaction, this is the interaction, you have not noted any significant difference. Okay, so this is a good one. That is, you have noted only the significant difference over the periods. Next, you will click test of sphericity, and again you have noted that it is significant 0.05 level. Next is test of between subject effects, and again you will find significant difference is there, 0.002. Okay. So this is also significant. That is the time. And now you can get the plot. Okay. So here you can find out three groups are there. One is control, treatment 1, treatment 2. You have noted that is the cholesterol level from lower to upper, and after that upper to lower. And this result is significant. So this is the three periods, 1, 2, 3. This is clear? Hello? Sophie, it is clear? Mona Lisa?
Yes, sir.
So this is the repeated measure data. Where you can use the control group as well as the experimental group. And Now, when you find out that is your data is skewed in nature, okay, and you have not followed the normal distribution, then you have to follow the non-parametric statistics. Ankit, it is clear? Ankit, it is visible? Non-parametric statistics?
Yes, sir.
Okay. So you have to click the non-parametric test. After that, legacy dialog. Then you have to go to the K-related samples. Okay. K-related samples. You have to click this one. And then you have to click the day 1, day 2. Is it visible?
Yes, sir.
Okay. Day 3. And after that, you have to click the statistics. That is the descriptive statistics. Continue. And next is the Friedman test. You have to check the Friedman test. After that, okay. And this is the result of the Friedman test.
Sir, output table.
Correct. So this is the output table. Three groups are there. Day 1, the mean is 131.44, 128.89, and 128.22. And the rank is day 1, 3, day 2, 2, and day 1 is 1. And this is significant. So in early study, we have already noted there is a significant difference in cholesterol level, and by using the repeated ANOVA, here also we have observed the three groups and the change in the cholesterol level. Okay. And this is significant. This is called the ANOVA with repeated measurement. But it is the Friedman test. It is the non-parametric test. And do not forget, it is the Friedman test.
Friedman test will give us the answer.
Yeah, Friedman test will give you the significance level of the repeated measures when the data do not follow the normality distribution. At that time, you can use this Friedman test. So
Yes.
this is the advantage of the SPSS. SPSS will provide you this knowledge. So this is the day 1, day 2, and day 3. 3 groups are there. But keep in mind, this is the day 1. So it does not tell you that is the group-wise difference. It can give you information about the day-wise difference, that is between days difference. Now, whenever you have noted the significant difference, then your function will be to do the non-parametric test, legacy dialog, then 2 related samples. If it is not significant, then this is not required. But if it is significant, then you have to click this one. Okay, now you can click these 2. First one is it visible? 2 related sample, is it visible? No. Now it is visible.
Yes, sir.
So first you have to click the day 1 and next is the day 2. After that, you can write down day 3. No, sorry, this one is day 2. Day 1 versus day 2, and the next one. You can click the day 1. Acha, it will not allow much. Only this one. Okay. So day 1 and day 2, whether there is any difference or not. So this is the Wilcoxon sign rank test. And then you have to click the OK. And then so day 1 and day 2, that is the between period difference, you have to show. So this is the Wilcoxon sign rank test. And you have noted that is it is 0.006. So this is significant. So day 1 and day 2 difference is there. And it is the negative value. Test statistics indicates negative value. That means day 1 and the day 2, 2 days are there. So score is high, score is low, and here the score is high. Therefore, it is negative value. Negative Z value. So this is important when you will find that is the Friedman test is significant. At that time, you can do this test. Otherwise, this is not required. Like that, in case of the general linear model, so this is called the post hoc test. This is called the post hoc test. This is defined. Here it is called the post hoc test. Okay. The group. After that, you can click the Duncan test or Tukey test. Many tests are there. You can click. After that, okay. So next, you will get this output. So here you have noted the significant difference. Test of between subjects. Now this is the post hoc test. Okay. So this is the control group and control group versus treatment 1. It is significant 0.05 level. And treatment 2, it is 0.002. Similarly, treatment 1 and the control like that 0.05 and this is the 0.04. So treatment 1 versus treatment 2 and treatment 3 versus control 0.002 and treatment versus treatment 1, treatment 2 versus treatment 1, you will get the significant difference. So in this manner, you can tell that is whether your group is significant or not. So this part is vital. If you find that is ANOVA with repeated measures by the groups are significantly different, then you can do this type of analysis. And this data already I have discussed. I think this is clear to all of you. Any more question? So this is the multiple comparison post hoc test by the group. So in case of the post hoc test, For non-parametric, we are getting the difference between the days, between days difference. But in case of the parametric, we can get the difference between the groups. So that is the advantage of the parametric test. And in case of the non-parametric test, we have to follow the Friedman test. So the outline is first one, analyze. Next one, non-parametric test. Next one will be the K-related samples. Then you have to select the day 1, day 2, day 3 in your model. Click descriptives, then OK. And after that, you will get the knowledge about whether there is a change in the dependent variable over the periods or not. This is clear, Sophie? Any question?
No, sir.
Mona Lisa, any question?
No, sir.
So I have covered the paper 3 completely. Now I am going to the paper 4. Paper 4 includes correlation. So I have to take another sets of data. I have to close this data set. This is visible to all of you? No. This is visible now?
Yes, sir.
So I have selected the Ravindic values data now. It is already with you. This is the SA1, SA2, SA3, SA4, SA5. And for item analysis, you have to click the analyze, then correlate, then the bivariate, then you have to click the first 5. You have clicked the first 5. After that, it is a two-tailed test because it is a correlation statistics. After that, you have to click the OK. When you click OK, so now you will find that is the output data. This is your output data. And you have noted that is this item 1 and item 2 highly correlated, 0.71, but it is not correlated with item number 3. This is not significant, but this is significant. Here you can find out 0.0001. That means it is significant. Significant is very high, 1 versus 2. And this number 3 item that is not correlated with other items also. Okay. For example, item number 3 is only correlated with item number 4, 0.31, but not the item number 5. So you may think that this item is not the good item. Good item means maybe for researcher point of view, this is a good item, but for the respondent point of view, this is not the good item. It may not carry much meaning to the respondent. So this correlation statistics is important for your analysis. Is it clear to all of you?
Yes, sir.
This is called This is called the inter-item correlation matrix. Inter-item correlation matrix provides you the knowledge about which item is not correlated with other items strongly. So this is the advantage of this intercorrelation matrix. So today you have understood three things. Number one, ANOVA with repeated measures. Number two, Friedman ANOVA. And number three is intercorrelation matrix of the items. And you have also understood how to do the post hoc test for ANOVA with repeated measures. And when the K related samples are there, how do you do the post hoc test in case of the Friedman non-parametric test. I think this is clear to all of you. So now here I am going to show you the graphs 1 and 2. You will get the scattered dot. Define I click y-axis. Two as x-axis. Okay. After that, I click OK. So this is the result. One and two correlation. There is a scatter plot. Now you have to click it. And then you will click this one. Okay. So this is the linear model. After that, you will click the file. Then close. Now you will get the result. Okay. Since it is highly correlated, you have noted that is the it is a straight line. And 49% variance it accounted. So y equal to a plus bx. Okay. Here you can find out the 49% variance. 49, 50% variance. So 1 unit change in the x-axis means another 1 unit change in the y-axis. So this is the line. From here, you click it, and then this is the point on the y-axis. So if for the item number 2, score is 1, then for item number 1, it will be this value. Okay. That means these two items, they are highly correlated with each other. It indicates it is a positive slope. Positive slope is there, and 50% variance it accounted. R square is 50%. So now you have understood another interesting thing. Since it is not correlated with number 3 items, I can show you the legacy dialog for the scattered dot. Simple scatter. I click define. Instead of number 2, I click number 3. And then I click OK. If I click OK, then I get this type of data. And you have to double click. After that, base fit line. And now you have noted that this is the base fit line. That means there is no correlation between the two. Okay. Now here you can find out the slope pattern, and here you can see the slope pattern. It is almost same line. Okay. It is straight line, almost straight line. It is almost straight line. And R square value here you can find out 0.02. So this is not the good item, but this is the good item. So again, you have understood that is the scatter plot for the item analysis. So today you have learned many things. Please you follow it thoroughly. Okay, thank you everybody. Happy Holi. Enjoy your Holi. Now I am closing.